If you don't know me, my name is Jim Vajda. Here's just a look at my background. I'm a wireless network engineer and chief wireless officer here at 7Signal. And today we're talking about Wireshark, and I'm going to walk you through how I set it up and talk about a couple ways that it's useful. But Wireshark is free and open source software. You can download it from wireshark.org. If you already have it, you should probably go get it again because because version 4, a very large new release, major release, just came out in the past few weeks. So make sure you have that. There's a lot of 802.11ax decoding capability that was added. Previously, you needed a development version of Wireshark, which was buggy and unstable. So go get that. And it's really a must for network engineers. You can use it for protocol analysis, for troubleshooting RF problems, even for PoE. The list goes on well beyond Wi-Fi, which we focus on here, but routing, switching, firewall issues, and so on. But it's particularly useful for Wi-Fi because there's so much sent in Wi-Fi packets that is clear text that's really useful, that's talking about RF measurements, at layer 1 and layer 2 protocols that are unencrypted, that tell us so much about what's going on. That can really be useful, and so Wireshark is a great tool for that. Now, a common way to look at packet captures is to say, the packet capture is the real source of truth, or sometimes it's even stronger put that PCAPs don't lie. Actually, kind of disagree with that. I think when you're doing packet capture analysis and protocol analysis, you have to be just as concerned as with the things that weren't captured in the PCAP as what was captured, and sometimes what's missing tells more of the story than what's there. So anyway. Don't get too overconfident with what you're seeing in packet captures. You really have to understand the protocols you're working with. But like I said, Wireshark is free and open source software, and as such, you kind of get what you pay for in terms of UI. And it's kind of intimidating. And for a wireless engineer, at first you open it up and see a default configuration like this, and you see the raw bytes down there, and you think, oh my goodness, do I need to know assembly to make sense of all this? I just, like the language of Wi-Fi is kind of hidden, and that's what I'm going to show you today, how to bring some of these things out and configure this. So Wireshark looks more like this. So now we've got some really useful columns. Our packets are colored so that we can get a visual indication of what kind of packet it is. All those, all the hex is hidden away because this is not particularly useful for what we're doing. And I'm going to show you how to build this. So the starting point for how we're going to set this up is this really, really useful Wireshark configuration profile that Joel Crane at MetaGeek has published and shared. And I will drop that link in the chat. But open that tab and come back, because we're gonna dive right in to sort of augmenting this. So what I love most about this is the coloring rules. This matches actually what MetaGeek uses in their other analysis tools, like IPA. So if you're familiar with those colors, then this brings it into Wireshark. And it adds a few columns too, but that's what we're really going to get into and go in and tweak and alter. But big thank you to Joel Crane and MetaGeek for sharing that. All right, so now I'm going to switch over to Wireshark and walk through how to get this all dialed in. So let's stop that. You know, we're using Zoom less and less, Heather, and I'm sort of not used to the UI anymore. Here we go. Okay. So again, here is Wireshark with an over-the-air packet capture that I've done myself. And again, out of the box, this is really intimidating. I don't know how useful it is to see the raw bits and bytes down there for most people. What we want to focus on is the Wi-Fi info, and the MetaGeek profile is a great start at that. So I've already installed it. They've got directions on their website that show you how to do that, but I'll just click on the profile drop down here and switch over to the MetaGeek Wireshark profile. And right away, you know, the things are getting cleaned up. And if I scroll through the packet list, got everything nicely colored. And now, you know, what was before just kind of a big table looked more like an Excel spreadsheet. Now I can kind of see, oh, okay. I can see the frame types, and the coloring tells me without even reading, right, that all these blue frames are data frames. So up here, there's no data being transmitted back and forth, just probing until we're authenticated, and then data frames start showing up on the channel. So that's a really nice way to get started. One of the things I'm gonna just walk through quickly, if your layout doesn't show up this way in the preferences, and I just want to confirm, Heather, can you see the preference window I just opened?
Yes, yep, we can see it.
Good. You have this option here under appearance to change the layout. And stock Wireshark comes with this first layout. I think this second one is better because we get more vertical space for looking at the contents of packets. And so if that doesn't happen automatically when you switch profiles, that's where you go and do that. Another thing I'm going to do is, and this is just personal preference. By the way, these are all just my own preferences. You can configure this however you'd like. But another thing I'm going to do is I'm going to change one coloring rule, because what you can see here is that here's a retried frame. You can see that Joel has marked that as a retry, but it's blue. And for me, I really like to see those retries jump out. So I'm going to go to, actually, here's how we can do this. Because this is actually a really useful way to approach manipulating filters and columns and a lot of different options in Wireshark. I'm actually going to dive into the contents of the packet, come down here into the layer 2 header, where we've got the bit that tells us if a frame is being retried. And this is set to 1, so that's how we know it's a retry. So what I can do is right click on it, and right clicking brings up a contextual menu. And one of the things I can do is I can colorize with filter based on what I just clicked on. So I'm going to say new coloring rule. It's going to bring up my coloring rules window, and now I can see all the really great stuff that Joel and MetaGeek have done here. I'll dump this one because that is a duplicate. And basically what I'm going to say is whenever there's an 802.11 retry, I want to just color it red. I really want that to stand out. So the foreground text is white. That's fine. The background, I've got my little color picker that's coming up here. And I'm going to just choose that same red color that they've used. And did I get that right? Oh yeah, okay. So I want to change the text color to white, that foreground color. And now as soon as I apply this, you'll see now that I click off of that packet in my packet list, it's red. And I like that because, like, sometimes you'll see just endless retries. A majority of the packets might be retries, and just seeing that red show up just for me is really useful. Another reason that's useful is that a retried frame might have been corrupted. If something's gone wrong and that's caused that to be retried, sometimes Wireshark, shows a corrupted frame incorrectly because the bits are not, there was an issue with the integrity of the data. So Wireshark got some bogus data and interpreted it like it was real. And it would say like, hey, there's this crazy frame that you wouldn't expect out of nowhere. And if I see, oh, it's a retry, I can say, well, maybe Wireshark is misinterpreting this. Another great thing now that I've got these coloring rules enabled is there's kind of like this macro view on the right-hand side. You can see as I scroll that there's this zoomed out view, and I can actually grab this slider and scroll through the whole PCAP. And just by looking at the colors on the right, I can see, oh, look, there's, something changed with the traffic pattern over here. I'll just click on that and see what was going on. Oh, it's a bunch of control frames, RTS, CTS. But maybe I'll scroll and see, I'll see more red pop up. And it's like, oh, okay, that's where retries were accumulating, right? Maybe that's where the problem that I'm looking for happened. Or, right, I want to find where data stopped going back and forth. Well, look at all these retries, right? Ugly, but not so, ugly, but also successful. You don't see a long string of retries. So very useful there. And so, okay, good starting point, but I like to do a lot of different things and have a more advanced view than what you get out of the box with the MetaGeek profile. So I'm going to start adding columns, and this is where we're going to spend a lot of time. But I think this is what makes Wireshark especially useful for what we do in Wi-Fi. So the first thing I'm going to do is, if I look at the packet contents here, I've got a few different groupings of data. The radio tap header, that's great. That gives us all the physical layer RF info that we might use for troubleshooting, signal strength, data rates, modulation, and so forth. And then the 802.11 radio information, this is kind of like a more sanitized, if you will, mostly physical layer data. And then here, this is the MAC, and in this case, it only has a MAC header because it's a block ACK. I'll actually switch over to a data frame here, and now you can see there's even more data. And because this is on an unencrypted network, we've got our layer 2 information, but also our layer 3 information. Here's our IP header, our layer 4 information, the UDP header, and then actually the data, which is, maybe useful if you're doing application debugging. But so what I'm going to do to start setting up some new columns, and this is really useful because it's not something that we do kind of one and done. Depending on what I'm troubleshooting, what I'm looking at, I'm enabling and disabling columns pretty frequently. So knowing the quick way to do this is really useful. But, one of the things that actually is not, let me just hide that, is not enabled right out of the box is signal strength or RSSI. And if I go into our 802.11 radio information grouping here, I can see we've got signal strength right here. I can right click, apply as column, and bam, there it is. So I've already set that up and renamed it RSSI. And the reason I did that is because I'm going to have a lot of columns and they're going to kind of be fighting for screen real estate. So I want to have a pretty short name. And I can do that again, right click and edit column, change the title to RSSI. Jonathan says MCS, not RSSI. Don't worry, we're getting there. So really useful, right? Because another part of like figuring out, if Wireshark got it right, or if we see like this crazy frame that doesn't look, looks totally out of place. Well, if the RSSI is really low, that's another indicator that maybe we didn't decode the bits properly when it was captured. But this is, of course, useful in a lot of different contexts around RF troubleshooting as well. So let's add some more. So Jonathan in the chat already calling out MCS. It's here. And, it's captured, again, in the 802.11 radio information area. And just like I did with RSSI, I can right click and hit apply as column, and bam, there's the column that I already configured. So now I've got this column where I can see the MCS value. I've already got the data rate that was there too, but watch my webinar on MCS and you can hear why I think that's a much better thing to look at. And actually, it's really, you look at those data rates, they're like 12 megabits, 650, 780. It's kind of not as intuitive as to what's going on. MCS is so simple, with 802.11 AC, just 0 through 9, and off we go. So I can see the rate shifting of this client as it's communicating back and forth with an AP, and get a just quick validation that of the modulation in use. Now, one thing that's a little bit unique about Wireshark is that our MCS values that it captures are PHY specific. So we have what I've renamed this VHT MCS because it's only going to show me the MCS of frames that were modulated with 802.11 AC. So I need other columns, which I've already created, and I'll share these with you at the end. For HT, that's 802.11n, and HE, that's 802.11ax, MCS values. So that's one of the columns that I kind of toggle, between, depending on what PHY I'm working with in a PCAP. Isn't usually useful to have all three of these enabled. Okay, so more stuff. So if we're still in the radio information, this mostly physical layer stuff, there's really useful information around frame aggregation and frame timing. So one of the things I'm going to turn on is, as a column, is the AMPDU aggregate ID, which I've just renamed AMPDU ID. This is really useful because, you just see this, this number increasing by 1. But as we Yes, here we go. So you might see, oh, look, that's the same number. And that indicates that these frames were transmitted within a single AMPDU. So that tells me frame aggregation is occurring. And it shows me what frames were all transmitted together. And oh, did my camera stop? Let me sort that out. There we go. I'm sure everybody's looking at my camera. There's another field that Wireshark has, which is just an AMPDU present, which gives you a little checkbox. Maybe you like that for simplicity, because then you can just see that check and say, oh, okay, now I understand these two frames were probably, since they're one after another, part of the same AMPDU. I like to see the ID numbers just, but personal preference there. So that's really useful. Another thing that is extremely useful and is in here is, where is this? The PPDU format. So I've already got that column set up. Yeah, that is it. Okay, so this tells us, and I just renamed it payload. It is this column, WLAN radio aggregate. It tells us what kind of frame this is. So these are all MSDUs. And brownie points in the chat if you can tell me what MSDU stands for. So depending on the PHY and depending on the configuration of the network, we might see other types of frames. We might see AMSDUs, and we might see some interesting. I think you'll see some different things here if they are if there's multi-user traffic. Tom with Mama still don't understand. Well, it's not that memorable, Tom, but I will probably remember Mama still don't understand, but I probably won't as easily remember that it's MAC protocol service data unit. There we go, Thomas following up. Yeah, MAC service data unit, not as good. MSDU is just a normal frame. There's nothing special about it, but when we're working with frame aggregation and multi-user stuff, it's helpful. So I mentioned there are a lot of good timing fields down here, and a couple of them that are particularly useful. And let me switch to a different frame. First is just the duration. This is really useful. Now, it's easy to misinterpret this. And I think I turned that on. I did. So what I'm going to do, that went off the window. So I'm actually going to turn off frame type, and I'm going to turn off SSID. Again, it's up to you if you want to use those or not. I like to just, use the coloring rules to understand the frame type. Oh, and the other thing that I like is just the information, the built-in information field that Wireshark has. This is a dynamic field where Wireshark just, depending on the type of frame and how much of it has been decrypted, Wireshark will just tell you what it, kind of a summary of the frame. So these TCP frames, are totally unencrypted in clear text. So Wireshark's going all the way out to that level, that layer, and telling me what's going on there. Now these block ACKs are just layer 2 info, so it tells me a little bit about that. So I prefer that view, a bit more advanced, but up to you. So I turned on the duration field as I pivot back to that, and I brought up a new column, and I've actually renamed it airtime. And the reason I did is because this duration field is showing you the duration in time in microseconds that the frame took to be received. And so there's a duration field in the layer 2 header that is not the same thing. Do not confuse those. So Yermund and I had a recent back and forth about that, and I know I was confused. So you have to be very specific. And I will look at that sometimes and think, well, what duration am I looking at? That's why I like to rename it airtime. So that tells us how long it took a frame to be received. And you can go further with that. I like to show preamble as a column sometimes, but you really have to have a specific use case for that. So I'm not going to turn that on by default. I am going to turn on IFS though. I'm going to apply that as a column. Anybody in the chat who can tell me what IFS stands for? And yes, I agree with Martin. Someone did a stupid job calling that duration. It looks like Ulysses got it right. Interframe space. So, and this is a Wireshark measurement. So it's not if you have a long string of packets of frames, you will see interframe spacing that kind of lines up with what you'd expect to see based on the rules of EDCA, where the interframe space should be a CIFS, which is I think 15 microseconds in 5 gigahertz usually. And so you will see that if frames are sort of transmitted back to back. But what Wireshark will show is basically how much empty time there is between frames as the IFS. So you see numbers like here where it's like 11,000 microseconds, and that's there isn't an IFS that's that big. So just remember, it's a little bit different from the way we think about it with EDCA. And I think we've got so that's all like the layer 1 info. The way I've organized this too is I've kind of got my frames or my fields left to right as columns, increasing in OSI layer. And now we're going to jump into the layer 2 info that we can get from the MAC header of the frames. There's a lot of really good stuff in here. I already showed you the retry bit and how we're using that for a coloring rule. But here is another field named duration. Okay, so and this is the name of the field in the 802.11 standard. It's the duration field in the MAC header. And I need to have this as a column, which I've renamed dir/AID. This frame actually, or this field has multiple uses. It could be the duration value or the association ID, depending on the context. This duration value sets the nav timer of everybody that hears the frame. So this is telling you how much more wait time there is after this frame is transmitted before the TX op is over, or the IFS and ACK that are expected are transmitted. It's not the duration and airtime of the current frame being transmitted. So important thing to distinguish there. Really useful though for a lot of different troubleshooting things. Okay, so I'm going to try and speed up a bit here and show a few more things. I want to show, so a lot of really good QoS information down here. Oh, one field before we get there is the sequence number. Again, layer 2 information from the MAC header. And if I turn that on, actually move that over here because it shows me with aggregated frames that these are unique frames. So if I find a set of an AMPDU. Let's see. It's not a lot in this capture because this was, yeah, here we go. This was capturing a voice call. So here, yeah, look at that. The sequence number is the same. So this looks like it's actually the same frame if the sequence number hasn't incremented. And that's also useful when we look at a block ACK. It'll tell us the starting sequence number of the string of frames that it's acknowledging. So 625 is way back here somewhere. Let's go back to a data frame. QoS stuff, really good stuff here. The priority, this is the layer 2 access category, the WMM access category. So I'm going to turn that on. I've just named this WMM AC. So here we're looking at a voice call, and right away I see, well, this is no good. This handset is sending all these voice frames as in the best effort queue, which unfortunately is usually how it happens. What else can we add here? Payload type. We already covered that. I believe you already covered that. I think that's already, if I go to apply as column, it should, yeah, give me that little error that payload type's already there. And one more thing that I like to get out of the layer 3 header is the DSCP value. So this is the layer 3 QoS, and actually that's not exactly the field. I will just turn that one off and turn this one on. This is Wireshark's kind of translated DSCP. This shows exactly in the layer 3 header what QoS tagging in DSCP is used, and those values are usually what's translated into that WMM tag. There's usually some mapping there. So if we don't see DSCP values, then we know that that's probably why the WMM is set to best effort 2. That info, by the way, I'll just quickly look at our columns in the preferences. This is where you can just define things arbitrarily too. You don't have to do that right click apply as column thing. And this is where you can go and get this info column and see some of these other things that are just built in. One other thing I want to show you, there are some filters that are built in here, and just like other things in Wireshark, I can right click on an address or anything else and apply it as a filter. So I usually use prepare as filter because I might want to clean this up, but I want to see everything that this Wi-Fi client received. If I go prepare filter, then I've got my filter there, hit return, it'll apply it. And now we see all the frames that were captured that were headed to that client. So I can right click and do that with anything in Wireshark. And I've got some canned filters up here on the right. Like I don't want to see all these probes and beacons. I just want to see the data and control traffic. I can hit hide management. And now I've got this filter built here. And I've augmented this with a couple filters that I've been using recently. The downlink multi-user, this is going to be blank with this capture because there's no multi-user traffic. And uplink multi-user, if you're looking to see if OFDMA has happened in your PCAP, which is like finding a needle in a haystack, you can use those filters to quickly see if there's any frames around OFDMA that were captured. So we'll share that too. So, and that's just a quick run through of how I've got Wireshark configured, and hopefully you've learned about the flexibility and have some of your own ideas there. This built profile, Heather, we've got ready to download. So if anybody wants to see our remixed version of the MetaGeek configuration profile,
I'll drop that
You
link in
can,
the chat.
yep, grab it in the chat. Cool. Do we have some
Sweet.
time for Q&A, or did I go too long?
Always time. There are a lot of questions though, so we may need to pick through these pretty carefully. Maybe I should have had you keep Wireshark up. Nick asked if you were going to be able to give some tips for capturing the 802.11 data using Wireshark.
Yeah, good question. I usually use either the Sapphire Eye, which Eric is all queued up to show us how to do that. Really useful tool for doing PCAPs. Or I use a MacBook Pro. If I'm in person, I'll use my MacBook Pro and the what is the name of that system menu thing? It is AirTool 2, and that makes doing packet captures on a Mac very, very easy.
Sweet deal. Let's see what else we got here. What hardware do you recommend for capturing on Windows? Air PCAP is outdated now.
Yeah, that's a good question. I would probably look at something like a WLAN Pi, just because you're not going to run into the Windows issues with that. It just use that as a remote capture device.
Mm-hmm. Yep, Steve is, as you were saying, the words WLAN Pi. He's like, yep, that one. Let's see what else we've got here. Is Wireshark able to see multi-user MIMO and OFDMA working?
Yes. Well, so multi-user MIMO, I've never seen it in Wireshark because I've never seen, I've actually never seen an AP try to do it. But the multi-user transmissions are very difficult to capture themselves, but there's usually some control traffic that happens around those transmissions. They're actually quite easy to capture. So there might be a basic trigger frame before uplink OFDMA, and that's just a single user OFDM modulated frame. And that tells you a lot about what's happening. So some of it's invisible, but you can still see a lot of what's going on around it.
Gotcha. Okay, and I keep filtering it. So Feng did have it's kind of a two-parter, or I'll just kind of condense it into one. So does duration count IFS? And if so, it won't be the real airtime, right?
So duration, let's be very specific. So the Wireshark duration measurement field, the airtime of the specific frame, does not include IFS. The duration field that's in the MAC header of a frame does include the upcoming IFS as well as the time that the acknowledgement is coming, will take. So I think they're both, useful in different contexts for figuring out airtime.
Gotcha. All right. Probably have time for one more. Let's see. Oh, the capture you did. This was one from earlier. So the capture you did, this was by spanning the AP port wire capture and not via wireless, ?
No, actually, that was an over-the-air packet capture. That's why we saw, the RSSI and so forth. The reason you saw the layer 3 and the layer 4 information is because which I often do when I'm testing and troubleshooting, just use an open unencrypted SSID. So we have more data in clear text to look at without having to worry about trying to decrypt it to figure out what's going on at the different layers. And Wireshark will sort of present the highest layer that it can decode. That's why when you look at the info column, you'd see TCP ports and things like that. on those frames or packets or segments. We'll call them packets.
Awesome. Well, there were still a couple. So if we didn't get to your question, just hit us up afterwards and we'll be happy to answer that offline. But I do want to make sure that Eric has time to emerge from his hidey hole and talk a little bit about Sapphire Eye. So we can go ahead and move into that segment. Eric, there he is. I love watching you emerge from the shadows. It's always a joy, always a pleasure. Happy to have you with us.
And I'm happy to be here. Yes, it was getting a little cramped in the hidey hole, so I am thrilled to be out into the open finally. And this is great stuff, Jim. Thank you so much. And right now, as you guys know, it's time for 7 Minutes with 7 Signal, where we take a little feature inside 7 Signal, unpack it, and show you how it can have huge value. And I'll tell you what, nothing more valuable than having this packet capture feature built in to 7 Signal. Let me show you. Hold on. So let's do a little screen share here. And away we go. Boom. All right. If you guys can see that, give me the thumbs up. All right. All right. So here we go, guys. So I'm in Sapphire Analyzer and I'm doing my, daily check of Analyzer. And I see, maybe I had some complaints about something that was going on. And maybe it was something that was going on over here on this end of the spectrum on channel 36 area here. So this is one of our access points. As you can see, a little bit of interference. Maybe there was a complaint. I want to know what's going on in that area. Now I am 30 miles away from the office right now, but you know what? I've got a Sapphire Eye there. And if I've got a Sapphire Eye there, then I've got an eye on what's going on. Now, in addition to having all of the awesome reports that are here with 7 Signal Analyzer, I can zip on over to the configurator, which is the portion that we use for more detailed control of a Sapphire Eye. And when I do that, look, here's the Sapphire Eye at headquarters. And what I've done is I've right-clicked on it. And when I right-click on it, I go to packet capture right there. I can basically invoke a packet capture remotely. And so here's what we're going to do. Capture the channel traffic. So everything going on in the channel, right? I'm going to do it for 1 second. I'm just going to keep it simple, right? And you'd be surprised how much you can get in 1 second. And I'm going to have it on channel 36, since that's the area of question that I want to learn more about. And this is a VHT 40 megahertz wide channel that gets me, because it's an AX, that gets me the AX, the AC, gets me everything that I need. And I'm just going to execute that packet capture. It's going to then just say, hey, are you sure you want to do that? And away it goes. Now, again, and Jim, I know that just in your previous experience in using 7 Signal and all of that, being able to do this without getting in the car is pretty valuable. What is going on in that building on the other side of town, or on the other side of the country, or on the other side of the world for a guy skilled in the ways of Wireshark like you are? I mean, tell me about how valuable that potentially is for you.
Well, it's just a huge time saver, right? Particularly when you're trying to track down that intermittent thing that happens every once in a while. It's not exactly clear why. And you just got to get the packets to see what's happening. And there's travel time. There's also time wasted just sitting somewhere doing packet captures for hours waiting for something to happen.
That's right. Yeah, what is going on? But if somebody calls you up and says, look, this is happening right now, and maybe this issue has been somewhat elusive, who knows, and you want to get the story, what do? You just do a packet capture, right? And right there on the spot, remotely. And just like what you can see on my screen right here, it took a little bit of time to kind of do its little thing and kind of stop its testing profile, do the packet capture, upload it to the cloud, and then it just downloads the file right to my computer. Here's the PCAP file right here. We open that sucker up, and then boom, it just launches Wireshark on my computer, and there you have it. And now what I'm going to do is I'm going to go back and I'm going to listen to Jim's webinar all over again so that I can learn how to customize my Wireshark so it looks as cool as his. What do you think of that? Right? So there you go, guys. I mean, just totally awesome stuff here. Again, don't have to get in the car and drive across town. Don't have to get on an airplane and fly across the country. You've got, with a Sapphire Eye, packet capture on site that you can do remotely, and you can just open this sucker up and pick apart these packets to your heart's content. So that's what I wanted to show you guys today. Want to just remind everybody how valuable this surely is. And, remember, we can't hear, we can't see Wi-Fi, but 7 Signal can. Thanks for having us, everybody.